Now that we've learned to integrate, name our peaks, and print reports, let's dive into a little more complex analysis. The first thing we'll start with is calibration curves. Let's build a calibration curve by clicking Edit Calibration Method. What you'll see pop up is a blank table, as well as a blank calibration curve on the right. So we'll start this by deciding the number of calibration points, or levels. If you have 2 standards, 3 standards, i.e. 3 concentrations, or 4, etc., you just continue to build up. What you'll see as we click through, a different column for each standard is shown here. So as an example, if we have our peak names, we can open a peak ID table as a shortcut. So as we've learned how to create a peak ID table, let's open one. So our PAHs is the one we've been using. If we open that and go to just channel 1, we'll see those 7 peak names that we saw when we named them and printed our report. And then we again select the number of standards. We then type in the concentration or value for each standard. For example, if they're all 1 for standard 1, we enter that value in for each, and 2 for each, and then you just type in the unit. If this is concentration, you can type that in. You can also copy and paste. And of course you can set the type, whether that's linear or quadratic. And in this case you can ignore, include, or connect 0 if you'd like. Once you've built that method, simply save as. Or in our case, we'll open the already created one so that we have the proper values for these 2 standards. And as you see here, the only thing that has changed is the actual values of 0.2 mg per mil and 1 mg per mil. Once you have saved your calibration curve, we're ready to start analyzing the data. Now, as mentioned, we have that recalculation sequence. So if we go to that, now we simply open up our particular executed sequence by selecting it and hitting open. And what you'll see is it populates our sequence. We will want to enter in by highlighting and dragging down the peak ID table, which we've already created as our PAHs. We just created our calibration method. Highlight down and open our PAHs again for the calibration method. And on the left side, we want to tell it whether it's a standard, which one, or if it's an unknown, meaning we're going to determine the concentration of that unknown based on the calibration curve. So the first one, as the chromatogram name tells us, is standard 1. The second one is also standard 1. So we have 2 calibration points for that concentration. The third and fourth are standard 2s, and as you see, the last 2 are unknowns that we'll determine the concentration of using our calibration curve. 2 more things we need to fill in. The mode, and if you click the drop down, mode simply means new, add, or blank. New means that we may have calibration points in this calibration method already, but we're going to start fresh and wipe those out. Add simply means we're going to add that calibration point, and you can also click and highlight down, and if you right click, add for multiple. Now for unknown compounds, the last 2, we leave those blank, meaning they're not going to be part of the calibration curve. Now the one last thing we'll need to do is we'll need to, of course, integrate these peaks, as we've only integrated the very first one. So we're going to jump to the data processing method. So click data processing method, and we're going to start, as you can see, with very intense data analysis opportunity here, but we're going to just peak find, which is our peak method. We'll select channel 1, or whichever detector channel you're using, and then when you click the ... and parameters, we're going to be picking our peak method, again our integration conditions, which we used channel 1. If we save this data processing method, integration for channel 1, and hit save, now we can close it and apply that. So now we're going to go ahead and hit this run button, and this is going to recalculate first by integrating, then it's going to name all the peaks, and then it's going to build a calibration curve with these 4 standard points, and then for the unknowns it's going to calculate the concentration of them. So we'll simply hit run. As it tells you, it's recalculating. And now if we go to our calibration curve and open it for the PAHs, you'll see we have generated our calibration curve. We'll just stick with channel 1. And of course, for each compound, we have our calibration curve, which slightly changes. Below that calibration curve, we have our formula, as well as our correlation value, and our data points. So of course, with each of these, we have 4 data points, 2 for each concentration. And now if you click on one, for instance number 1, you'll see it turns blue. We can zoom in. If we click on number 2, that's the other data point. Should we have an outlier, we can simply uncheck the box and you see it turns red. And you'll notice our formula has slightly changed, as well as our correlation. To bring it back, just simply check it again. If you were to uncheck and want to keep that, of course you'll have to save and update this calibration method and then reapply in the recalculation sequence. With these calibration curves, or any chromatogram, you can copy to clipboard simply by right-clicking and copy to clipboard. You can then paste it into Word or PowerPoint or any other format. We'll close, and we do not want to save any changes. So now let's look at the chromatograms and see how they were affected. So if we go back to chromatogram view, of course this was the very first chromatogram that we integrated and named, so that of course already has all the information. But let's go ahead and open multiple chromatograms, the rest from that sequence. The PAHs, we want to open 2 through 6. We can open those all at the same time by hitting Shift Control and then simply clicking on the first and last, and you'll see they all get highlighted. Once you hit open, you will see it has now opened all the chromatograms on the left, and the one in bold is the one we're looking at. As we scroll through, of course, all of them will have integration names as well as retention times above. And one value we'll add as we're looking at the unknowns, if you go to View, Information Items, we're going to add the quantity. Click OK. And now we'll see that it has calculated the quantity based on the calibration curve of each of those peaks. Again, unknown number 1 has the same. And if we look at the standards, of course it says NA because these are the standards as we know the concentration of each of the peaks. And lastly, now that we've done a calibration curve, we have that calibration method with the data should we need to open that at a later date. Simply double click and you have all the calibration information that was used to generate the information. Now that we've built a calibration curve and have the correct quantities for our unknown samples, we may want to add that to the report. Again, we'll go up to Edit Report Style, and we can start by opening our default report. And now the only thing we're going to change is into our peak table. If we go to the Details by clicking on Peak Table and the Details tab, we now can scroll down and we'll want to show that quantity column. Double click to show it, and now that quantity column, as you can see, is into the table. And now for the unknown samples, when we print out this report, after we save it, we will have that additional quantity column in the printout of the report as well, so that we know the concentration of each of the peaks in our unknown samples. Now we've learned how to integrate, name the peaks, and build a calibration curve. And then we learned how to apply that calibration curve to unknown samples. Now we've done it a few different ways. Within each of the methods, we've applied that. We've gone to the recalculation sequence and applied our ID, integration, and calibration methods. Let's learn the third way. So if we first remove the integration, for example on the unknown sample number 2, by clicking the manual peak process button, let's go ahead and remove all the peaks by clicking the erase button and hit OK for each one. Once we've done that, we'll accept the changes by clicking OK, and we'll save this data. Now, let's learn how to apply that peak method, the integration conditions, the ID table, as well as the calibration curve that we've already made to this unknown sample to determine our quantities. To do so, click the peak process button, and now we'll simply select the peak method, which is pH's channel 1, the peak ID table, which is indeed the pH's table, and then our calibration method, which is also the pH's calibration method. Now we can click Execute All. It'll warn us that it's going to override our manual peak processing, in which we erased all the peaks. And we say that's okay, hit yes. And now if we close it, we'll notice we're back to our integration, our naming, as well as our quantities for that unknown sample. Now this peak process can only be applied after a calibration method has been made by labeling the standards in that recalculation sequence that we've done. Only unknowns can be applied to the calibration method in order to determine the quantity, as you cannot tell which standards are which within that table. Once you have, of course, integrated and named and applied the calibration method, as you see there's a star, we just want to save so that all of these data analysis features we've just done stay with the data.